Georgia is now the host. And so do you want to press record? All right, so we're recording now. Ready? Okay, so thank you for tuning in, everyone. We are recording this. We'll put it out on our website and social media and send it out to the RiverTrekkers, those who haven't been able to make it. And Harley has been a no stranger to river keeper. He gave a talk to the board a couple years ago. And also he's met us at Means Creek, which is named after his father, I believe. And he can talk more about that. And Means Creek is a very unique spot where it's a slot creek. It's like a canyon along the river, mini canyon with a cave and everything. And Harley is a geologist. And so he is an expert on the geology of the Apalachicola River. And we're going to see Allen Bluff. And Allen Bluff, last time we saw him, I think he actually was down on a boat. We were hiking along the bluff, and he was on a boat with a group looking at fossils on the bluff. And so he's going to share some slides, and then we'll just have an informal chat about the geology of the area and maybe some other things that he wants to discuss. So I'm going to turn over to Harley Means. Thank you so much for coming.
Hey, thank you, Doug. Yeah, it's really nice to see everyone. I wish we could see everyone in person and not through these dumb social platforms like Zoom, because I have been on a Zoom meeting almost perpetually since COVID stormed into our lives. But anyway, we'll make do. What I'm going to need you to do, Georgia, is if you will give control over to me. I need to share my screen. See, maybe you've already done it. Can you guys see my screen yet? Good? All right, super. Okay, so this, Doug actually referred to this talk. I gave this talk a couple of years ago to the river keeper down in Apalachicola. So hopefully it won't be redundant for all of you, but it's got some things in it that I think may help you as you navigate the upper part of the Apalachicola River. These are some great things for you to look for and recognize as you're going down one of Florida's iconic rivers. So a little bit about the river, and this may be stuff you guys already know, but Apalachicola River is Florida's largest river by discharge. And interestingly, it starts right there where you're going to put in at Chattahoochee, right below the Jim Woodruff Dam. The river is about 106 miles long from there. The Apalachicola River and its floodplain and adjacent uplands are well known for both the endemism that exists there from the flora and the fauna. And it's known as a biodiversity hotspot, but not too many people recognize it for what it is geologically, and it is quite unique with respect to the geology as far as flora goes. So as you guys are traversing the river, as you're heading from north to south, and you're looking at some of these geologic exposures along the way, you'll maybe keep in mind that the oldest rocks you're going to see are going to be right there where you launch your canoe in Chattahoochee. You'll start to see some limestone exposures if the river's low enough, and those are Oligocene limestone units. And as you head further south, ultimately you get younger and younger until finally you're going to see nothing but Holocene deposits from the massive erosion and deposition that the Apalachicola River has done. So some of the geologic features of interest for you to keep your eye open for, particularly in the upper part of it, include karst features. And hopefully everybody is familiar with the term karst and knows what karst features are. But for those of you that are not, karst refers to landforms that form in areas where the geology is underlain by rocks that are susceptible to being dissolved away over geologic time. And it leaves behind unique features on the landscape that include things like sinkholes, disappearing streams, springs, and caves. And all of these things are things that are pretty abundant in much of Florida. But not not as abundant as you get out into the Panhandle region. So you're still in kind of a unique area there in the upper Apalachicola River. Some additional things to keep in mind is, from a geological perspective, is that at the boat landing at Chattahoochee, that's a famous locality because it is what geologists refer to as a type section for one of these geologic formations you're going to be seeing, and it's aptly named the Chattahoochee Formation. So when geologists go out and they look at rocks and they find rocks that are of similar nature and similar age, and they map them, they have to refer back to the place where they were originally described. And that's essentially what a type section is. So this river system has two type sections. One is at Chattahoochee, like I said, and the other one is at Rock Bluff, which you'll pass by as another one of the really nice high limestone bluffs. And the rock exposure right at the river is called the Torreya Formation, and that's aptly named as well. So that is another geologic type section, and this is the only place in Florida that I'm aware of that has two of them in such close proximity. This river system can also boast having cut into and exposed the tallest natural exposure of geology in the state of Florida at Alum Bluff, which is one of my favorite places in the world to go and explore. And as Doug said earlier, I have picked up, no doubt, many, many tons of fossils from that locality. And there's some great geologic formations that are exposed there that have some pretty amazing fossil faunas. The largest tributary to the Apalachicola is the Chipola River, which you guys, I don't know that you go around the cutoff where you'll actually see the confluence. But the Chipola is a huge spring-fed river system, and it's quite amazing in and of its own right. Some additional things to keep in mind: you'll have to venture, up and into the uplands to see some of these things. But there are some very unique types of ravines in the Apalachicola River Basin, and they're called steephead ravines. And a great place to see them is at Alum Bluff, and I'll show you some pictures of them here in a minute. And then, of course, as you get further and further down, you get into the Apalachicola's massive river delta and estuary, and then you see the spectacular barrier islands that occur as a result of all that sediment that is being eroded from ultimately the southern Appalachians and being transported down the Chattahoochee River, which ultimately becomes the Appalach, and all that material has made it that far, which is pretty amazing. So for those of you that don't know, the karst that exists in the upper reach is pretty amazing, but can you imagine what it must have looked like when they were constructing the dam, and as they're digging down looking to set the pylons, this is what they encountered. These pictures show the massive cavernous porosities that exist in the limestone bedrock there. And these are pictures that were taken as they were actually building the dam. So right there at the dam, you're actually going to see something pretty cool, which is the result of all of this cavernous porosity. There is a great big huge spring boil just below the dam on the west side of the river. And hopefully you guys kayak up to it and see it. But it can be at times, depending on the river stage, it can be a massive boil. And it turns out the water is actually lake water. It's not true groundwater discharging from the underlying aquifer system. It's just found a pathway underneath the dam through some of this cavernous porosity, much to the chagrin of the Army Corps of Engineers and the folks in Alabama and Georgia that like to dispute with us how much water we get from them. But again, the oldest geologic units you're going to see are in this upper reach, and they are limestone units. Here's a picture of this spring boil that I was just referring to, and it's just below the dam. You see the dam there, and it's pretty cool. You guys ought to go check it out. There are additional springs that you'll see as you head down river, and these springs are occurring because of the limestone and its proximity to the surface. So as you get further and further south and you get away from these limestone units, you're going to get away from the influence of any of these springs. This is a spring up right on the edge of the floodplain, right below the Woodruff Dam on the west side that emerges from the bank. And once again, you see from the color of this water, it doesn't look like nice, clear spring water that we're familiar with seeing in many of Florida springs. That looks like Lake Seminole water, and that's exactly what it is. So the lake level, the head pressure on the lake is driving water and under the dam and around it through these karst features. And again, some people might call that a dam breach. And here's what this limestone unit looks like. This is the Chattahoochee Formation. And again, this is an actual spring discharging from the Florida aquifer system. So you see the difference in water clarity here, and you'll also notice a difference in water temperature. So if you were to put your hand in the boil up by the dam, it's warm water just like the water in the lake, and is the same temperature. But you put your hand in this stuff and it's probably about 68 degrees and is nice and clear. And you can see these springs when the stage at Chattahoochee is usually about 40 feet or lower. So it has to be pretty low for you to see this exposure and see these springs. As you head further south, there are other springs like Blue Spring. This one is a spring because it does discharge water, but it's also a big sinkhole. And you'd see that from an aerial shot of this if you were looking down on it. It's a nice, perfect circular lake-looking feature with an outlet. Now, if you don't believe me that there are springs in the bed of this river, I've actually witnessed them. I have some video of one. Now, this isn't a massive spring. This isn't discharging, huge volumes of water, but you can see it's issuing up through the bed of the river here. And if I were to fan down through all of this sediment, I would eventually hit limestone bedrock, and I would find the orifice that water is coming out of. But there are a number of these features all along the upper reaches of the Apalachicola River. And that would be my oldest son. Yep. You can see the temperature differential there. It makes the water a little bit cloudy. Kind of interesting. Anyway, so more about some of the karst features. As Doug was telling you all earlier, unfortunately, I do not believe you are going to be able to see much of Means Creek. It turns out that the damage from Hurricane Michael was so substantial that the tree damage and down trees are probably going to make it almost impossible to get up and see the neat stuff that is exposed in and along Means Creek. So you have to take our word for it. But my father, Bruce, for many years used to take classes out and show people how amazing this part of the world was. And he would always take people to this little creek, which remained unnamed for a number of years. And he would come down and take people through this neat, almost a slot canyon, if you will, for Florida, and show people salamanders and snakes and all kinds of neat stuff and the neat plants. And I guess he visited it so many times that finally the name stuck, and it's now known as Means Creek after him. But if you hike up far enough, you actually get to a part of the creek that actually does go completely underground, and there is a nice series of caves that you can go through if you're interested, and if the tree damage isn't too bad. So again, as I referred to earlier, there are two type sections I won't go through all of this. You guys can have access to this PowerPoint if you're interested. But again, right down from the landing, when the water level is low enough, this is what you'll see. And this limestone unit is known as the Chattahoochee Formation. It's an early Miocene limestone unit that's probably about 23 million years old. And it was deposited during a time when sea levels were much higher than they are today. And the climate was much warmer as a result. And pretty neat to see this far inland, a limestone unit full of all kinds of marine organisms. Again, here's the type section at Rock Bluff. This is known as the Taria Formation. And again, unfortunately, I was there just a couple of weeks ago. And although the park has done a great job of clearing out the trails and you can hike down to it, there's enough tree damage here that this bluff doesn't look nearly as spectacular as it once did. But it's really interesting, and you'll notice a difference in the limestone between here and Chattahoochee. The limestone at Chattahoochee is more uniform, and when you get down here, you see it's kind of blocky and more undulatory. And it's not only is it a different age, but it was deposited under different marine conditions. It's about 19 million years old. And then finally, you guys will ultimately get down and you'll get to see Alum Bluff, which is the state's tallest natural exposure of geology. And it's pretty spectacular if you have not seen it. And again, I hope the river is low enough for you guys to take full advantage of all that Alum Bluff has to show. So the geologic units that are exposed at Alum Bluff include the Citronelle Formation up here at the top, which is a non-fossiliferous unit. And it sits on top of this neat looking gray material, which is an organic rich clay, and it's full of all kinds of marine fossils. It's known as the Jackson Bluff Formation, and it's probably about maybe 3.2 million years old. And it in turn sits on top of another formation called the Alum Bluff Group, which here is an undifferentiated formation within it. And it's unique because it also has fossils, but they're not marine fossils. It has the fossils of plants, including some really, really spectacular palm fronds. In fact, there are some pretty spectacular examples of the stuff down in the Florida Museum of Natural History. And in fact, one of them is, huge, almost completely intact palm frond that came from Alum Bluff many, many years ago. And then finally, right at the rivers, right where the river touches the bank there, you'll see the Chipola Formation. And the Chipola Formation, again, is another one of those incredibly highly fossiliferous marine units. And you'll recognize it right off the bat because it's almost white. And as you approach it, it's white because it's just chock full of literally billions of mollusks. So you'll see all kinds of gastropods and pelecypods, and they're really quite spectacularly preserved. And here's just a couple of photos of what these units look like. So going from the base upward, the oldest to the youngest, this is what the Miocene Chipola Formation looks like. You see all these beautiful shells that are preserved in it. And, geologists in particular have been studying these geologic units at Alum Bluff for many, many years. And a lot is known about these faunas. So if you're so inclined and interested, I can point you to some papers that outline all the neat fossils that you can find in these things. Another really, really interesting recent discovery is this neat dome structure here is actually a thing called a stromatolite. And for those of you that don't know, stromatolites are actually trace fossils, so they're not really body fossils. In other words, it's not a skeletal remain or an impression of something, but what it is it's something that was left behind by blue-green algae that lived and coated whatever surface this was in a shallow marine environment. And as the blue-green algae tendrils grew up, it baffled and trapped sediment. And then as that continued, you got these nice layered features. And these are these are really famous because these are some of the first fossils, these are some of the first representatives of the first life forms on Earth. And Australia is world famous for having modern stromatolites in Shark Bay, but also having some of the oldest ones preserved as fossils that are on the order of several billion years old. So this is a really neat recent discovery that we found at Alum Bluff when the water level was low enough. So here's that Alum Bluff group undifferentiated, and what you'll see here is you see all these nice angled beds. This is reflective of probably a river system or a stream system, much like the streams that occur in and around the Apalachicola today. And they deposited these dark layers here, which are where you will find the plant fossils. So believe it or not, you can go chip this open, and much of it looks like, you know, leaves that were deposited, you know, last week. And it's pretty amazing to think about, you know, they've been sitting there for 18 million years. Really, really interesting. And here's what some of these things look like. Here are the fossil palm fronds. Here is a big chunk of wood. So there's a bunch of organic material in this. And, you know, these were described and named, and of course this one is named Apalachicola appropriately so. And finally, we get to the Pliocene-Jackson Bluff Formation. This overlies that plant-bearing unit. And again, you'll notice when you see it, when it's weathered, you know, a lot of it's going to be crumbled and tumbled down from above. And if it's sat and weathered long enough, you're going to see all this white material, which when you get up close to it, you'll see will be just literally hundreds and thousands and millions of marine organisms. And it's well known for its fauna, including this really interesting and unique gastropod known as Ecphora, which is prized by numbers of collectors. But you can also find shark's teeth, including megalodon teeth. Megalodon teeth have come from here pretty regularly. So it records a pretty interesting period in Florida's prehistory when those giant sharks roam the seas eating whales. And if you're a fossil hunting professional like this young lady is, that happens to be my niece, Harley Means, and she's holding her first shark tooth she found at Alum Bluff. So you guys might take a minute and kick around the base of the bluff, and anywhere you see you know, these fossils that are concentrated, you know, scrutinize and look closely, and you're liable to take away a nice fossil treasure to remember your outing by. Not that you need something to remember it by. And then finally, when you get to the top of the section there at Alum Bluff, you get this big giant sequence of, really it's just sand and gravel, and it's known as the Pliocene Citronelle Formation. And that's this is really what caps most of the hills from this part of Florida all the way over, really all the way over into Alabama and all along the coast. So this is a pervasive geologic formation, but you're not going to find much in the way of fossils in it. And finally, the last big bluff that you're going to boat past is right at Bristol. And what you're going to see exposed here at Bristol is that unit that we saw at Alum Bluff that has the plant remains. But I want you to pay close attention because it's a little different. The section is a little different down here. And you're not going to find the really thin beds of fossil leaf impressions. But what you are going to see are these huge, massive carbonized logs sticking right out of the bank. And again, you know, these aren't modern. This isn't something that was deposited by the river in its last flood stage. These things are as much as 18 million years old. So stop, take a look. Along here too, occasionally you'll find pieces of petrified wood where iron deposits have replaced the wood. So again, here's another opportunity for you to see some neat fossils and some neat prehistory. Here's what some of this fossilized wood looks like, which was really unknown to the Florida Museum folks until the river got low enough where I started seeing it. So they got a nice collection of it now. So, you know a little bit about the Chipola River, which is the largest tributary to the Apalachicola. Jackson Blue is one of the largest springs really in the Panhandle region, but it is the largest and is a first magnitude spring that discharges into the Chipola. But for those of you that have, you know, are avid canoeists and kayakers, I know you've been all up and down the Chipola, and you know how special it is and how many springs it has along it. So at least 63 different springs have been identified up and down the Chipola River, and it contributes quite a bit of groundwater to the system. We talked a little bit earlier about the ravines. So what you'll notice is if you're looking at the topography, this is a digital elevation model of this part of Florida. And you can see here that the ravines that have been incised into the topography here have a different pattern than these ones when you get down here towards Bristol. And it's because the geology changes. So up here above Alum Bluff, most of the ravines you see are what we call gully eroded ravines. And these are there because the underlying material is resistant to erosion. It's clayey, and the water actually has to cut down into it, and it as it cuts down into it, it doesn't slump quite as readily. But as you get down towards Alum Bluff, all of a sudden you get that big giant section of citronelle formation, which is all that sand and gravel, and it sits on top of the Jackson Bluff formation. So the citronelle is highly permeable and porous, but the Jackson Bluff formation, that dark unit, is clayey and it is impermeable. So, you know, Florida gets a lot of rain, between 50 and 60 inches a year. And when you put that much rainwater into something that is as permeable as the citronelle formation, it's going to go straight down and it's going to hit that impermeable layer, and it's going to look for an outlet, which in this case is the Apalachicola River. So these are special features called steephead ravines because they erode in a completely different fashion. They don't form these gullies. So I encourage you, if you have a minute, walk up one of these steephead ravines and also walk up one of the gully eroded ravines. That way you'll be able to see firsthand what the difference is, both topographically and even faunally when you go up into these things. They're pretty unique. And here's just a shot showing you, here's one of these slots in Means Creek, which is a gully eroded. Actually, this is probably more related to a fracture in the limestone bedrock and the water eroding down into and following that fracture, as opposed to the steephead ravine here at Little Sweetwater Creek. But you get the picture. And again, here's just a close-up showing you, this is a classic dendritic pattern of erosion, because all this material here is somewhat resistant to the infiltration of rainwater. And then when you get down to about right here, you start to see a difference in the drainage patterns here, because each one of these is a steephead. And this is more trellis-like drainage. You can also see something too. You see on the imagery here, I'm assuming everybody can see my cursor. Any idea what these things are here? If you've driven State Road 12 down towards Bristol, you cross over these features. It turns out this is a big paleo dune field. And this paleo dune field is full of sand. And again, it's that big giant package of sand that sits on that impermeable Jackson Bluff formation that causes this particular kind of erosion. And that's why the steepheads are here. And then finally, you guys are going to get down. It won't be perceptible to you on your kayak, but you'll be down in the delta, and ultimately, as you get to Apalachicola, you'll be able to look out across the estuary but you can get out here and get lost in the distributary channels. And again, you know, this all of this sediment that is out here that forms all of these barrier islands, including St. Vincent, and even over here to Cape San Blas and St. George and Little St. George, all of that sediment worked its way down ultimately from the southern Appalachians and was deposited by this massive river system. And here's just a shot showing you a little bit about what St. Vincent Island looks like. This is a digital elevation model, but it just really highlights all of these coastal features that make up this unique area. So quickly to recap, you guys know the biology and ecology of the Apalachicola River is well known. It's really, really cool. It's diverse, it's unique, lots of endemism, but don't forget about the geology. They're intertwined. And I always like to put a picture of Dan up there. Hopefully everybody knows Dan. He's done a whole lot for this area and deserves our appreciation. Anyway, I'll end with that, and I'd love to entertain any questions you all may have or any comments, or maybe you're ready to go get your own beer. I don't know.
I have a question.
Hey, Harley.
Oh. Sorry, I'll go first, then you can go, Rick. I was just curious. I get so thrown by the concept of time and these like millions and billions of years ago, and just how to even understand that. And I was wondering, do geologists have some like special secret, or like how do you wrap your head around millions and billions of years ago?
You know, Kim,
Or do you just talk like that and you just like?
No, that's a good question. You know, it probably has to do with how our brains are wired. You know, if I were an engineer, you know, plus or minus a millimeter is a big deal. To me, as a geologist, plus or minus a couple million years, no big deal. And it really just, it comes from, you know, studying about geology and just, you know, I don't think anybody ever really comes to fully understand and appreciate the breadth of not only geologic time, but, you know, certainly the time that our universe has been here. But as you go out and you look at outcrops and you look at these accumulations of fossils, and you learn about how old they are, and learn about, you know, how quickly these things can accumulate. You know, over time, you do slowly start to get a better feeling for millions of years versus, you know, just a few tens of years. And, you know, I always like to say, you know, geologic processes take place over geologic time, and very seldomly do we ever get to see a geologic process that occurs, you know, on a time frame that we can see. And you can sort of see that in the Apalachicola River. You see where the river is cutting and so, you know, these processes all have different time frames, and you just learn to appreciate and keep learning. Sorry, I know that wasn't a specific answer, but
No, I mean, that was really good. And I mean, talk about, I mean, as geologists, I feel like you must just feel like just a speck in the universe, I guess. You know, it's just,
we do.
it's just amazing to me. And it's amazing when you're going down that river, how much history, I mean, you're going by history, you're going by geologic history, you're going by fossil history, you're going by, you know, and biodiversity. It's just, there's so much, and it's hard to take it all in, but I love your presentation. It's so informative and just,
Thank you.
Just amazing.
Well, you know, so, and a big part of it that we didn't talk about is how much time is missing. I told you how old some of those deposits were, but we didn't account for all the time in between those deposits to show for. So something else to consider is, all right, if I've got 23 million year old Chattahoochee Formation, and on top of it, I've got 18 million year old Chipola Formation, what happened to those millions of years in between? Why is there nothing there? So it turns,
That'll be next.
yeah. So either nothing was deposited there, or it was deposited and it was eroded and removed from the section. So one thing geologists are always having to deal with is the incompleteness of the rock record. And in no one place can I go and say that there is a record for every year that the earth has been around recorded in the rocks beneath me. It's always punctuated usually by massive amounts of missing material and missing time.
So what are the ways that you date these layers, Harley?
Mm-hmm. Oh, what are the ways?
Yeah. How do you date these layers?
So the best and most accurate means for dating geologic strata are what we call geochronologic methods. And usually most of that is related to looking at things that are radiometric techniques. In other words, you have radioactive elements, they decay over time. We know how they decay. In other words, we know the rate of decay. So if you look at the parent versus the daughter, you can derive an age. And so, you know, most of the really good dating that has been done on rock strata are done through radiometric techniques. Now, we don't do that on all rocks because not all rocks have, you know, radiometric means by which they can be dated. So what we do is we do correlation. So for instance, say the Chipola Formation, I said it was 18 million years old. Well, what if it doesn't have anything in it that I can date, but it does have fossils? Now, what if another unit has the same fossil fauna from somewhere else, and it does have something in it that we can date, like uranium? Then what we do is we make a correlation. We can say, all right, this has the same fauna. We know it's probably the same age. We dated it here, therefore it's the same age over here. So radiometric dating is really the primary means geologists use. But there are other techniques, and we're always being innovative and coming up with new techniques, particularly in areas where you just don't have a lot to date.
Hey, Harley, you had mentioned you were showing the picture down below, I think it's Stephanolga, Bristol area of the log. And you referred to it as
Bristol Bluff, right.
Yeah, you referred to it as a carbonized log, and then you
Right.
also said petrified. And I was just curious, is there a difference between petrified and carbonized?
Yeah, so that's a good question. Petrified typically means that the woody, fibrous cellulose material has been replaced by some kind of mineral. And in this instance, the logs have not been replaced by anything. They've simply degraded into their constituent carbon, right? That make sense?
Okay, so almost like the actual fibers and what have you have been
Yeah, so you
preserved?
absolutely. In fact, you can go cut into them. You can dig into them with your hands, and you'll see when you pull your fingernails back, they're all black from the carbon. But you can, yeah, they're still well preserved. You can look at the cell structures, and paleobotanists have looked at some of that stuff and made some determinations about the species that existed there. In fact, there are a number of master's theses and professional papers on the fauna the flora from both Alum Bluff and this Bristol outcrop. And it tells a neat story about what the climate was like back then during the Miocene. So quite a bit different than today. So, you know, the difference is carbonized doesn't necessarily mean it was replaced by some mineral, and if it has been petrified or replaced, it's going to be hard as a rock, right? You'll find both there, interestingly.
And those were 18 million years old. Did I remember that correctly?
Georgia, they're younger than that because they sit on top of the Chipola. The Chipola Formation is 18 million years old. This stuff is probably probably somewhere on the order of maybe about 15. So it's from what's called the middle Miocene. And then again, we're missing a bunch of time between Chipola and that unit being deposited. And we're missing even more time between that and when the Jackson Bluff Formation was deposited on it.
Thank you.
Harley, what's the going theory as to why there's missing time? Does it correlate with ice ages where water was being sucked up rather than discharging down the river, or?
Yeah, so yeah, that's a great question. In this area, what it probably correlates to are sea level changes. So when sea level is high enough to cover the entirety of the platform, we get marine deposits like the Chipola Formation. Well, we all know that sea level has fluctuated drastically in the past, certainly over the last 2.6 million years during what geologists call the Pleistocene epoch. But actually sea level has fluctuated all throughout geologic time. And even during the Miocene, there were quite a bit of sea level fluctuations. So what happens is when sea levels are up, you get the deposition of marine units like the Chipola Formation. And when sea level drops, you don't typically get a record of what the rocks look like because you're having a whole bunch of erosion take place. Because if it was deposited, it was then subsequently eroded away and not preserved. Kim, I
Great,
see you
thanks.
waving loudly. Am I doing something?
No, I'm good.
Okay.
No, I think Georgia accidentally muted you. I'm calling
Oh,
her
shit.
out.
Hey, don't show my wife that trick. But actually, Kim,
Other questions?
that was just specific to our area. There are other reasons in other parts of the world why there are significant time breaks in the strata. Just depends on where you are.
Thanks.
You're welcome. Anybody else? You guys getting
I
excited?
heard you say fossiliferous. That is a real word, correct?
It is, absolutely.
I'm going to use that on the
My
track
office
this year.
is fossiliferous.
If
Y'all are
we
going to have
have-
to spell that later.
If we have time, Rob Diaz de Villegas, he did a video with you on Allen Bluff, and it's what, 5 minutes? You think is that worth showing, Harley?
It's not worth showing to me, but you guys might benefit from it.
But for
I
the
vote
group-
yes.
So,
That's totally up to you guys.
well, thank you very much, Harley. And I'm going
Yeah.
to go ahead and show this video because videos
Okay.
really tell a lot. So,
Mhm.
Georgia, make sure you shift it to me so I can share my screen. And I have the video.
Well, thank you, Harley. That was great.
Thank you so much.
Yeah,
You're very welcome.
Thank you,
all.
Harley.
all day.
Thank you so
Thank
much.
you.
You're very welcome. You're very welcome, Cameron.
And can you all see this?
Oh. I'm gonna sign out. Love you all.
Okay,
Stay safe. Stay healthy.
it's only a few minutes, but you'll see Means Creek and some other places.
I'm in this video. By the way. I find the banded waters.
Good show, Harley. Enjoyed it.
Good. Thank you.
My students love this video.
Some of the best places for me as a geologist are on these rivers, where the river does.
The Upper Apalachicola River contains some of Florida's most visible geology. On day one of RiverTrek 2016, we'll explore some rocky places.
We'll keep that tab over the bridge if we can.
These kayakers will travel 107 miles down the length of the river. However, they'll find some of the most memorable adventures off the water.
the drill that we usually do is we stop here at the mouth of this little creek, which is called Means Creek. And we have a Means right here. There he is. That's Harley Means, son of the legendary Bruce Means. Some of my earliest memories are slogging through some of the steephead ravines looking for salamanders and snakes.
What's the common name?
The southern dusky salamander, and helping my father inventory some of these unique animals and plants that are only found in the Apalachicola Basin ravines area. One of the really, really neat things about it is that not only is it neat for my father's niche in science, ecologically,
Banded water snake.
but it's really neat from a geological standpoint. This limestone is early Miocene. It's somewhere between 20 and 23 million years old. So what does that mean? What was going on here where we're standing 20 to 23 million years ago? This is limestone. Yes, we're under a shallow sea, and it was warm, tropical sea. This limestone was accumulating as all kinds of organisms lived in the nearshore marine environment, died, accumulated.
Walking down Means Creek, we see more remnants of this ancient sea.
These are the remains, the ribs are sticking out of the actual Chattahoochee Formation there, of sea cows or dugongs. Not many places in Florida can you walk along a creek that is incised down into bedrock where you get these nice sort of canyon walls, and you can walk along and you can see these beautiful exposures of geology. And here you've got the Chattahoochee Formation exposed.
And the water is low enough. The first day of RiverTrek ends at the Allen Bluff Sandbar.
Allen Bluff is known as the tallest natural exposure of geology in the state of Florida. Depending on the stage of the river, there can be as many as 100 to 120 feet of exposure there. And there are multiple geologic strata that are exposed as well. It's just one of the few places you can go in the state to look at millions of years worth of geology in exposure and not have to look at a core or a set of cuttings. Right at water level is a distinctive sort of whitish, sandy deposit, but what really jumps out once you start to look at it is that it happens to be almost a shell hash. So there are, literally millions of shells embedded in this sand unit, and oftentimes you get a nice whitish color because the shells are leaching and they're bleached white. Not everybody can get excited about a fossil shell, but I believe everybody can get excited about fossil sharks, particularly beautiful, big fossil shark teeth. And here are two great examples from Allen Bluff. And, I can't guarantee that you'll ever find one at Allen Bluff, but they are there, and this is proof of it right here. This is a fossil mako shark, but this is the real prize. This is what a lot of people are after. This is the meg-tooth shark, Carcharodon megalodon. If you do a modern comparison looking at what we believe is a relative of this beast, which is the great white shark, if you do a comparison of its tooth length to its body length, and you do the same for this, it turns out this creature could have been in excess of 50 feet long. Why do I keep going back to Allen Bluff? I've been there over 100 times in my lifetime and counting, and I'm going to continue to go back, and it's because every time I go there, I see something different, I see something unique, I see something that gives me now a bigger and better picture of the history of the area. So it's great. All we gotta do is get out and look.
Every RiverTrek gives us a chance to see something new about the river, whether it's from the living present or the distant past. That's what keeps luring me back. You never run out of things to see, in or out of the kayak. For WFSU, I'm Rob Diaz de Villegas.
Okay, that's a great video, and we'll end with that. So, does anybody have any last minute questions? Because otherwise, we'll let you go off to your dinners. And some of you I will see on RiverTrek next. So thank you so much, Harley.
2 nights
You're
at Allen
welcome.
Bluff.
Good luck, RiverTrekkers. Have fun. I'm jealous.
Thank you.
Thanks.
All right.
Thanks,
Take
Harley.
care.
Take
Till
care,
next
everyone.
time.
Bye.
Job.
Thanks, everybody.